Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
Before we jump into today's conversation, a special thanks to PM Power Consulting for encouraging and supporting this show right from the start. With over 1,000 person years of collective experience, PM Power has helped many organizations, teams, and individuals chart out their own journeys of excellence and make progress. Thank you, PM Power. Now, let's move to today's episode. My guest today is S Parthasarathy, better known as Spart, who is the co-founder at CuedIn Technologies. In this episode, Spart shares his extensive journey in the software engineering space. His story begins with his initial projects in COBOL programming at Tata Burroughs and then at the World Bank, working on critical systems in retail, logistics, and financial sectors. He recounts his impactful stint at Swift, contributing to the foundation of what has become the modern-day financial messaging system. Spart reflects on his decision to pivot from electrical engineering to computer science, driven by his interest in engineering of large systems. He details his experience at Ramco Systems, implementing document-based transactions, model-based code generations, and achieving several technology milestones, including internet integration and 32-bit upgrades. After Ramco, Spart's continued passion for software engineering led him to co-found a SaaS-based ERP solution company targeting SMEs. Despite early challenges and market readiness, he gained crucial insights into cloud-native architectures. His career path then took a turn towards exploring artificial intelligence and consulting, specifically focusing on probabilistic graph learning and challenges of natural language processing. He emphasizes the importance of non-functional requirements, application architecture, and the potential of tools like Gen AI to enhance the software development process. And we conclude by reflecting on the ongoing evolution of software engineering and his current projects aimed at making software engineering more accessible and efficient with modern tools. Listen on. Hi, Spart. Welcome to the Software People Stories.
Hi, Shiv. Good to talk to you again, and thanks for inviting me.
This is something which I'm assuming will give me an opportunity to find out something more about you, even though we've known each other for a long time. So how about starting with your origin story and how you got into IT, what are the things that you've been doing, and then we will take it from there.
Sure. So, Shiv, we went to IIC together, did my electrical engineering. So I was basically an electrical engineer, even though I knew programming and stuff like that from my BSc days. The first campus interview was Tata Burroughs. So I joined Tata Burroughs following as my senior. So I got into IT right out of college, but I wasn't still sure whether I would like to be in IT at that time. And the first project was in Memphis, Tennessee. This is like down south. So we went, it is for a departmental store chain. So it is basically retail and logistics place. And those days we were basically doing all COBOL programming. And so this is an interesting story how I got that name, Spart. So we went there and we were asked to introduce ourselves. The name was too long, so they told me to write it on the board. And typical Indian way, I write it as S Parthasarathy, right? So the guy called Rajesh Stone, there was the head of IT there, basically said, we'll take the first 5 letters, so he'll be known as Spart. So that's how I came to be known as Spart from the first project onwards inside TBL and generally in this industry, right? So we were there for around 3 months, and that was the year when it was Reagan recession. The retail chain didn't do well, so the project was cancelled, and I moved to the World Bank in Washington, D.C. to continue with project there. And I've been always lucky to work in projects where there were a lot of TBL engineers. So it's not like I was alone or anything like that. So I could basically talk to people, figure out what to do and stuff like that. So in World Bank, I was there for 1.5 years. So 1.5 years. And there it's again Burroughs computers, COBOL programming, stuff like that. So I was part of disbursements area in the World Bank. So I did a lot of interesting stuff. And that's when I was getting to know how programming is done in the real world, in the corporate world at that time. So I learned a lot during those days. And after World Bank, TBL, Tata Burroughs, sent me to Swift. Swift is the current Swift network we see, and it was actually developed, engineered by Tata Burroughs people mostly. So we were 80 of us in Culpeper, Virginia, which is a remote village outside DC in Virginia. So we were the original team which built the Swift. So that was a very interesting project. Till that time, till Swift, I was basically planning to save some money and go back to school for master's in electrical engineering. So I was not fully bought into IT at that time. Okay. So my plan was get into master's in electrical engineering. But in Swift, the way it worked was very interesting, right? The R&D was in Brussels, development center, Culpeper, Virginia. Those days, no email, nothing, right? So there's nothing. So we used to get all design and design documents by snail mail, meaning post. We used to get tons of documents written by people in Brussels using the kind of editor that was there in Burroughs those days, text editor, and it was sent to Culpeper. So we were supposed to take it, and then based on where you are assigned, you are supposed to come up and talk about the functional design. Basically, you have to present the design for that particular functional area. That was a great experience because we had very sharp people in Swift those days. These guys, there was one particular group of people from IIT Bombay, and I was basically in that group called Regional Processor Node. This is the first node to which banks connect, and then it connects to switching, and then it goes, right? So in Regional Processor Node group, these guys were there, and they were very tough to deal with because you had to go through, present your design, and get their approval before you can even start coding on that particular. So learned a lot about design and what kind of questions we should be taking care of and stuff like that. So it was a great experience. So I was getting slightly interested in this whole thing. And the one thing which really intrigued me was such a huge system being built with the documents sent from Brussels, right? 80 people sitting here and some 40 people in R&D, and they were sending documents, and we were trying to build the system, and the system seems to be working, right? I was part of a node called regional processor, like I told you. And in that area, we were working on directly using the disk, using algol primitives to manage the file systems because the messages cannot be lost. So we can't use the operating system because it buffers. And if the buffer is lost, the message is lost due to some downtime. So we had to directly write to disk. So I was in charge of what they call a safe or directory, which is the directory management for those message files. And I was feeling proud that, oh, these algorithms are great. Then you talk to somebody in the group and this guy told me, oh, these algorithms are already there in operating systems. It's nothing. You found out something, right? That's when it hit me. And I said, listen, if I'm going to be in this field, I need to get some formal background, meaning formal computer science degree. So that's when things changed for me. So I basically decided, okay, I like this field. I particularly like the engineering aspect of large systems, right? I said I have to stick to this field and I have to get a degree in computer science. So I gave up my dreams of electrical engineering. I said, okay, let me stick to computer science, but I will work on software engineering side. So I was not particularly keen on domain and stuff like that. I was just interested in how to build large systems. Right? Okay. So for that, the best way to do that would be to find a job in the US, right? So since I worked in the World Bank, those guys were happy to take me back. So joined World Bank, and I joined in July. I had written, even during my World Bank days, I had written GRE there. I could use that score and get an admission into Virginia Tech Extension Campus, Virginia part. So I joined World Bank mainly to finish masters in computer science and then figure out, because that would give me a stable visa and I don't have to worry about anything else. It was a G4 visa, so I don't have to worry about anything else. I can do this. So I joined World Bank and simultaneously, immediately actually joined the MS program. That basically happened. And when I went back to World Bank, things were pretty interesting because whatever systems they had, which are file-based, were being moved to transaction-based. But that is the same thing, right? So immediately I was in that project, and that's where I learned about the transaction processing funders. So I was interested in what you would now call as 4GL kind of stuff too, those days. And I used to try a lot of stuff, and a lot of stuff worked, and a lot of stuff didn't work. I knew why it didn't work, kind of thing. So it was a big learning. So in any career, the first 7 to 8 years, you're just learning, right? So I didn't particularly worry about whether I liked it or not. I just learned a lot of stuff in those 7 years, including my master's, which was going on in the background. After 4 years of consulting, these guys gave me a permanent job at the work. And that comes with a lot of perks and stuff like that. So I became a permanent guy called system officer or something like that. And not only that, at that time, what happened was whatever we moved to transaction processing area needed to be moved to the emerging client server those days. This is like in the 90 beginning, right? So by that time, I was basically in charge of what they would call as special projects, controllers, vice presidency. So any special project that needs to be done would come under me. So I was basically doing all the new and interesting stuff those days. We even built the Extat 400 system, communication system over LU62 protocols those days across DEC, IBM, and VAX for people to actually send out disbursement requests to cashiers, and cashiers would basically pay the money into the banks and stuff like that. So it was integrated to Swift. Since I was in Swift, and one thing I learned in Swift was, which will come in very handy later on. What we do in Swift is we actually create messages in a certain format. So when a Swift terminal ST, whatever, sends a message, then it is done with curly braces and stuff like that. Without wasting space, you basically tag each of those fields and the values are put. This is the precursor to XML and stuff like that later on. Okay. So this was what was used in Swift. So when I went to the bank, I created such transaction exchange, standard document formats between cashiers, disbursements, and controllers. But 3 different environments. So people were really happy. So I was basically involved in all these kinds of special projects. So obviously I was pulled into the group which did the technology selection for move to the client server. Those days Mac also had come out. It has come out, and somehow these are all political decisions, right? They decided that we are going to run on Mac. Windows 3.1 was cranky those days, so they went to Mac. So I had to go. We basically went and learned how to program these interfaces in Mac, meaning base code programming. Then I decided, looking at the kind of skills we had, that's not going to happen for such a big project. So I pushed looking for a 4GL, and we actually found one called Omnis from Blight Software, which is a UK company, and those guys are great. I mean, I really liked it. So a lot of things I learned from Swift really helped me later on. So getting an engineering environment set up was the thrill for me, for people to work. So I was involved in all that. So we set it up, and it was a very successful project. For the first time in the bank, those days it was a $12 million budget. And we finished it within budget by time. It was the first time that happened in the bank. So it was a very successful project. This time it was, one of the things we realize as people is the more you get involved in projects that see the light of the day, You get more confidence about your ability. Okay. So if you are in a series of projects which never saw the light of the day, you don't have that confidence that you can deliver anything. Okay. So I was lucky to be associated with projects which always saw the light of the day. Okay. That is one big, I would say it's providence. I mean, that's how it happened. So that was very interesting. So this was delivered. So it was around 95, right? 95, we delivered this project. It was rolled out all over the world. So I went to Indonesia and Delhi to train the users and stuff like that. So it was a huge success. And like any successful projects in corporate, there are many fathers and all kinds of things start happening, and people were being asked to go to other divisions and stuff like that.
That sounds very interesting. A lot of new things and applying technology as it evolved. What happened next?
By that time, I was pretty much bent upon working on the engineering side, having done this and seeing Swift and stuff like that. So I wanted to basically become a software engineering expert.
Okay.
How do you engineer large? How do you engineer software? Forget large, small. How do you engineer software? How do you think about it? That is what always interested me. Not only that, in my MS, I also did my thesis was actually what we call as domain-based AI layer over normal databases. So basically, the domain, the DB schema has a lot of semantic knowledge, and you can build rules based on that for running your. Those days, expert systems were rule-based, okay? Not neural networks, so rule-based. So how do you build such rule-based systems using the knowledge in DB schema is what I worked on. That thesis went well. And actually, Virginia Tech, these guys were asking me whether I would like to continue for a PhD. I said, listen, for PhD, I had to basically be resident in Blacksburg for 1 year and stuff like that. I have to ask World Bank for a sabbatical. I don't know about the visa status, so I basically said no. So I can do that. But anyway, so this was my interest. So basically 2 areas. One is AI those days, and the second one is the engineering of large software systems. See, when you work with people, particularly in World Bank, there are a lot of insights. Right? When you build these things, for example, one lady who used to work with us came and asked me, Spart, I have a question. Why the hell are we working on the back end? Whatever the user sees is on the screen. Shouldn't we start at the screen? Okay. Which was an eye opener for me. I said, what are we doing? So we used to conduct these case workshops and explain to these business people what entity is, what relationship is. So you tell me what loan entity will have. It was a mess. People would sleep, but there was nothing going on. The case tool usage actually failed in the bank when we tried to use it. Computer-aided software engineering was a pain those days. The engineering area and the AI area, these 2 areas were what interested me at that point. So I said, so what am I going to do next? So I said, listen, if I had to do something on my own, because remember, in a career, first you are learning, then you get some responsibilities like I did in World Bank, where you get confidence that, okay, I can make decisions, technical or otherwise, and get stuff done. So that is the point I was in my career. So now you're basically saying, listen, I need to do something which is more interesting and more responsible and accountable. And for that to happen in a typical corporation like World Bank, it is tough. Because remember, when you work for these companies, their core business is not IT, right? And IT is always a support service for that business, right? So if you work like that, you're always basically thinking about business solutions, business objectives, and how you can build systems for it. Okay? What happens is you're working with a budget given for meeting that objective. There is no special budget for doing your own research to build better systems because that is not their core business, correct? So I decided that I need to move to IT product side for me to be able to do that kind of a work. Okay. So now I have 2 choices. I can look for a product company in the US or I can look for a product company in India.
Yeah.
So from 95, 96, 97, whenever, so World Bank gives you annual leave, right? So you can go to your home country. So I used to come here and search for companies, product companies. There were zero product companies those days. And I would still talk to service companies to find out, but I was not very impressed with what I found out, what they are trying to do, and what they would use me for and stuff like that. So I was here 2 years searching for the job. But luckily, what happened was in World Bank, I met a person who was a friend of the CEO of Ramco Systems. Ramco Systems was the only product company in those days when I came back, real authentic product company. Right? They were making ERP, trying to compete with SAP and stuff. Luckily, I got that introduction, so I wrote to them and said, I'm planning to come back to India, but I was looking for a product company. I'd like to work with you. So what happened was in 96, I came to India and attended 10-day meetings in Ramco. So they would pick me up, take me to the office. They were planning to do something at that time. So I was part of those meetings as a pure observer.
Okay.
Didn't contribute. I just sat there, listened to them, and I was actually very impressed, right? Because these guys were doing since you have to build a product, the whole thinking is different, right? When you build a product, you are thinking about quality built in because you can't charge for a change request. Okay. Whole idea is totally different when you build a product, and the way you think about building software is very precise and engineering wise. Otherwise, you can't maintain that software, right? So I was very impressed with the kind of ideas. And Ramco was actually, the vision was led by a person called Venkatrama Raja, who was the chairman's son of the Ramco group. He's a MBA from Raw School of Business, University of Michigan. That guy was really great. Yeah. So I talked to him and I attended these meetings and found 3 things which we'll come to later on, which was very interesting to build on, right? So I told them, listen, I'm willing to come back, no problem, and fixed a date. Okay. So everything was peaceful, the transition. So we moved in 97 back to, and I became the technology person in the technology group in Ramco. Remember, Ramco Systems was a large group at that time. I was part of the tech R&D at that time. And so I joined, and 6 months after I joined, the head of technology actually left. So I was asked to take over technology. And so basically in Ramco, what I found was they were basically working on 3 things. One is there was a clear idea about sending transaction documents from the front end to the back end, not just SP calls. And the second thing is, these guys had a very good understanding of model-based code generation. See, what they did was, for their client-server product, to extend that product, they built what is called UDS, or user-defined screens. And the third thing is, these guys were basically into ISO 9000, which is for products, which meant that they needed to have a very clear engineering process which can be audited. Okay, it's not SCACMM, it's actually ISO 9000. These are things I noticed, and the way they talked about, and they used to call Marshall, and they wanted to call this active Marshall, and there were a lot of dynamic stuff. So because these guys have suffered in the field with having to implement multiple requirements on the same code base, managing the code base, this is humongous, the problem, right? So these guys are trying to re-architect and build this, and that is exactly when I came in. So it was very interesting. So I joined and started working on it. The initial days were very tough, because these guys didn't even have a build discipline. So we used to ship DLLs to the site, and it would crash with blue screen. And you would see that the Ramco client never crashed. It's Excel that crashed. We used to get calls from the clients, right? So first we had to bring in that build discipline for them. And that's what I worked on initially. So to bring in that build discipline. And the second thing was, these guys were slightly behind using 16-bit code and stuff like that. Okay. And also SQL Server 7 was being released at that time. So luckily what happened was, I was part of a customer meeting this guy Swatch used to be our customer in Switzerland. Okay. So, and there, the bill of material explosion is something like 150,000 components and stuff like that. So our systems used to suffer because we basically sold them a discrete production ERP. And so I used to go to these meetings, and these guys used to complain a lot, Swiss, how they talk. So realized that then I went to a Microsoft conference in New Orleans because Microsoft was a very close partner for us. So we used to be very close to Microsoft because we were the only guys making something on Microsoft at that time in India.
Okay.
Basically upgraded the existing software to 32-bit and to use SQL Server, Server 7 and replication and stuff like that. So that basically gave me some breathing space. Remember, I came here to work on interesting new stuff, not to maintain the existing stuff. But I had to do this. So the first phase was that. And then we started working on the what they call as active marshal. But anyway, the name changed later on. So we were working on that. And basically, we decided that we should give those times internet has come. And we basically gave an internet gateway to our client server product.
Okay.
For those kind of activities that could be done over internet, right? So done it and really, so Sports Council Singapore used to be our customer. So we released it for them. It even won awards and stuff like that. So that gave me another breather space because now I'm also internet ready, so I can enable my clients with internet facing activities. Why I'm saying all these things is when you get in and try to do something you want to do, you need to go through and take care of the tactical requirements before you can meet your strategic goals. That's what I want to convey, right? So you need to take care of what is needed now for you to be working on because you can easily get frustrated. Remember, I came from US wanting to do stuff, but these are the things that were staring at me, and I could have simply said that, oh, this is not going to work because I want to work on that stuff in these cases somewhere. It's not going to work, and I could have quit in the sense that I could have left. But I didn't do that because these are what is needed now, and these are also interesting problems to solve. So we solved that and got myself breathing space to work purely on R&D for the next gen architecture.
Okay.
That is important in career, right? You go there with certain expectations to a new job. You may not get to do it immediately. So you have to bide your time. You have to take care of how to get there. That is important in career. Thing is, by that time, okay, Microsoft was not the only thing. WebLogic, WebSphere, Entity Bean, Session Bean, all those technologies have come up and people were asking, can you deliver in those technologies in ERP? So it's a very key decision. So I already have 800 people in the company trained in C++. Now, how do you re-architect and rebuild this ERP to take care of multiple technologies? It's a big thing, right? I could simply go ask the management to budget it to 50 crores or whatever it is and get people and do all that tamasha, but I was not interested in it. I was not very confident about that succeeding at such a large scale. So we decided that we need to build an engineering platform which would generate code in any language we want. That is the fundamental approach. So that's what we started working on. No problem in Ramco because they anyway knew how to generate code out of software specification models. Right? So we basically went and built what is called as Ramco Virtual Works. The name was given by me. So one great thing that happened was before I joined, remember, all these ideas were there in the company and I developed. I didn't bring anything new to the table. The core ideas were with the company. They were already talking about it. That's why I joined, right? So remember I talked to you about people using transaction documents between client and so that has many implications because that's how we came up with what is later on we would define with IBM as SOA. It's some transaction processor in the Microsoft which they released. I forgot.
MDS, I think.
Anyway, that one or WebLogic or Sphere would be able to take that document and invoke the procedures and stuff like that. This is how we were built. So that particular point was very interesting because this is what they have thought about and that's how we built it. So these became service endpoints. So later on, this is the concept which IBM and us worked on to define SOA, okay, service-oriented architecture. Okay, so this was built. So it is very important to componentization, because if you think of components, software components are, let's say, ICs, right? Integrated circuits. The external pins are the services, right? Then you basically decide that this component holds what? It holds persistent data and logic. So how do you componentize it, right? That is the whole idea. And then the service endpoints, it's not just service endpoints, right? Because in a typical ERP, you are invoking from the UI, another UA from another component. So there is a UI-UA interaction. And for performance reasons, certain components may need to directly see data in the other component. So we're basically thinking about all these architectural implications and defining a software component, right? So that is one part. That is pure what you call as ninth floor R&D part, right? Now, how do you make 1,000 people follow this? Now, how do you make them follow this? So that's where we built the engineering platform and the code generation.
Okay.
So 1,000 people can do what they are told to do, build their ideas, and they don't have to worry about all these things. So what is a component and how does it map into functions in a business process? These are the kind of things we worked with the actual product managers and built this engineering platform. Built this platform and we delivered a complete re-architected suite of Ramco products fully on this. Right?
Okay.
So after that, okay, this happened and we basically filed for some 16 international patents and got 12 or 14 or whatever it is. I don't even remember. There were a lot of patents that Ramco filed and got based on component-based, model-driven software development or engineering area. Right?
Okay.
And those patents are mostly what they call as fencing patents. So that if somebody else does it, they don't come and sue you.
Yeah.
So that's why. So they did not aggressively take that patent or monetize it or whatever it is. It is just basically a defensive patent. So this happened. And after that, what I did was I basically wanted to. So that is when this platform was named as Ramco Works. And the reason for that was I wanted to basically take the platform and create what is called as a virtual shoring business. See, those days, onshore, offshore, all those things used to be talked about.
Right.
So I wanted the platform hosted on the internet and people can work from anywhere and create and deliver code. Because remember, this engineering platform not just had dev, it also had ops, meaning it could deploy stuff into the server. So there you would basically create a topology of organization units, functions, and physical hardware, and it will know how to deploy generated code into the hardware, right? So it's a complete DevOps platform, engineering and DevOps platform. So I wanted to take this onto the internet and basically build so we even named my SBU Virtual Shoring Solutions, right?
Okay.
Virtual Shoring Business. Try to create that SBU, but Ramco, from a philosophical point of view, wanted to remain as a product company. This would mean they're trying to dabble into services. So that didn't go well. And that's when I said, okay, but at that time I was in Ramco for 9 years. So I had a great time, fantastic time, that's all fine. But at that point, I had to make a decision saying, what am I going to do? It's like the World Bank decision, right? So that time I said, listen, so far I worked on some ideas, I worked to basically help some business in my career. Then I came to this product side. I basically helped them realize an idea they had. It's still not mine, whatever they had. We worked on it. Now I had to go think about doing something on my own.
Wow. That is getting interesting. What happened after that?
So at that point, I left Ramco and joined with Partha, who used to be the Aztec founder. So we used to joke that it's Parthasarathy.
Yeah.
Both are Parthasarathy, both are S Parthasarathy, but still. So we created a company, and at that point, I was actually very interested in software delivery through SaaS. So software as a service, we were one of the pioneers. Even in Ramco, ERP and cloud is because of our architectural strength and the way we used cloud, right? So basically at that time, Amazon has just come, Azure they're talking about and stuff like that. And when we started this company, I told Partha very clearly that, listen, we are not going to run a conventional company. We'll do it on the cloud. I don't even want servers in the office, nothing. We'll do purely on the cloud. Just give me Wi-Fi in the office. That's fine. We'll buy the laptops or desktops, and people will work from here. And by that time, since I had done this software engineering, componentization, stuff like that, one of the key skills is how do you create work package for people? Stuff like that was, I've become quite comfortable with that. How do you split a large project into chunks of work package that you can assign to the team, get it done, track progress? That's basically engineering management. Okay? So by that time, I was very clear as to that's the way we'll do it. And Partha he's also a very forward-looking guy, and he also agreed. And now, when you realize internet came and you can deliver software over the net as a service, right? So as a service, that was very interesting for me. So I told Partha, we are going to do what is then coming to be known as SaaS kind of. Since I had worked in ERP for long, by the time I knew all the problems with code maintenance, implementing changes, managing base code, all kinds of stuff, and customers coming up with all kinds of requirements, and trying to figure out how to fit all those things and stuff like that. So when I thought about SaaS, we sat down and I told Partha that, listen, we'll do it for MSMEs in India.
Okay.
And I always believe that if you take ERP to the cloud, ERP kind of solutions to the cloud, it has to be very specific, right? Meaning you should be able to load your master data and the cutover transactions, and you should be up and running. That's why you see most of the SaaS businesses now are only horizontal, like CRM and stuff like that. You don't see any core business solution coming on the cloud because nobody figured out how to do very specific. What we decided was we'll do specific micro vertical SaaS.
Okay.
Since I came from ERP, I knew the standard business processes that need to be built and stuff like that. So we basically took up forging, spinning, these machine works and small hospitals. Four domains. Where we built it was we would hire a very involved consultant in that area, even auditors for these companies who know the business process, and build it very specifically for that particular industry. You won't believe it. We started out saying spinning, eventually ended up doing 3 products, one for cotton spinning, one for synthetic spinning, one for blended spinning, because the processes were slightly different.
Okay.
So 7 or 8 products, which are specific micro vertical products. And the marketing was simple, right? So you're basically saying that go with the Barter's cluster theory. These things happen in clusters. So we identified some 12 clusters in India for spinning, some 14 clusters in forging and stuff like that. All you had to do was you go to these are associations in those clusters and sell it to them, saying that we'll run it, the subscription based, it's on the cloud. They don't have to buy hardware, nothing. They can cut over very easily. They give their master data, whatever it is. They can onboard themselves freely, or we appoint a local channel partner to do it. So this is what we thought we would do. But we went to the market, if we eventually realized we were too early for the market. People didn't understand cloud. The internet bandwidths were not really up to speed. Everybody was worried about, will it work without internet? So no point if it happened. India at that point, and even today, is in a revenue growth, non-saturated markets, and you go sell them cost optimization, they'll say, my Ramakrishnan will take care of it.
Okay.
So, you don't need here. So these are the things we learned. And so by 2011, we were at it for 4 years from 2007. Right? We realized that this is not going to go anywhere. But by that time, we were one of the only product kind of people on Azure, AWS, and stuff like that. So I understood this cloud fund, what is going on and stuff like that. How do you build systems for cloud and what are called as now called as cloud native architects. Those kind of channel partners were tough to find. It was tough to roll it out into the market at that time. So Partha and myself we decided there's no point pursuing this further. We had to shut it down. And at that time, one of my friends, my IAC classmates was in IBM. He basically said, why don't you come to IBM? I told him, listen, I didn't come all the way back here to join another service company. No. But he said, why don't you? So I, to be within quotes, look at it as a sabbatical because I know how to work in corporates. And I wanted that break because it was intense till that point after coming to India. So I said, okay, let me go check it out. And so I basically was with IBM in the Cloud Center of Excellence. The reason they hired me was to help people move workloads to the cloud, their cloud. And I was also part of the cloud architecture group. It's more of me giving than more of me learning about how to build cloud infrastructure. I didn't bring much to the table in that area because I was never an infrastructure person. I was with IBM for 4 years, and during those days, they were trying to move Watson onto the IBM cloud. All these platforms that came up those days, which are known as data science platforms and data machine learning platforms, didn't succeed much because people were asked to upload their data into the platform. Corporates were not ready to upload their tons of data into a cloud and expect something out of premises and expect something to happen, right? And these were, remember I told you about my master's thesis working on database based.
Yeah.
So that kind of kicked in. See, remember, I never forgot that goal. Whatever I did on thesis, my thesis should be implemented as a rule-based stuff. People specify rules and the systems behave like that without having to write code. Now that all this learning has come, I got interested in probabilistic graph learning, which is Bayesian statistics, right? Bayesian is the beautiful thing in studies. The only beautiful thing I liked in statistics, which is conditional probability, right? So I have an idea of building a Bayesian causal graph over database schema. Okay, when this idea came up, I said, listen, I've had enough with IBM. I'm in the third phase of my career where I'm going to work on my idea with my money. Remember, the career progressed like this. You learn, you got money, you worked for somebody, then you came to Ramco, their ideas, but you helped them implement it as strategic and higher level. That is fine. Then you went and started one with a company where the funding came from somebody, so came along with whatever that is required to oblige to at that point. So that happened. And then I took this break, and now I said, listen, I'm going to put my money and my idea and let me see how it goes. So that is the phase of the career. Because now I could afford to, financially you're reasonably secure and your kids are doing well. So it's okay. So we could take that risk. So that's when I started this, and I had an opportunity to consult with hedge fund in New York, and where they were trying to build a credit score prediction using the customer behavior, spending behavior. So very interesting. So I went and worked with them, and there were people from MIT and all those places, data science guys who used to work in this learning side. After that consulting ended, I said that, listen, even if I build it, I have to do a philosophical battle in the field to sell it with corporates and people. I don't have that much funds to, so that's not going to happen, right? So we basically shelved that and started working on another interesting idea, which is, listen, how do you develop software for mobile? I'm not very happy with the way people thought about mobile screens as smaller web screens and user experience built to it and stuff like that. Came up with an idea called stimulus-driven mobile development, where you basically say that who are the participants, what is the exchanges they make, and the exchanges drive to what action deal. So we came up with that framework and used that to build a core messaging stuff on mobile to which you can attach any transactional activity. So I wanted to take it further and said that, listen, let's do one thing, let's build a platform for local vendors and local consumers for daily essentials, which is a very sticky kind of a deal, where I wanted to have local vendors talk directly to the customers and customers talk directly to the shops, enable that and build a mobile platform. And that's what we built. And tried to roll it out, and then Corona came, all those kind of stuff. But that is something which kind of is there, it's lingering on. I need to figure out how to take it
Oh,
out. But in the meantime, Gen AI came up, ChatGPT came up, and I was thrilled to listen to the advancements, mainly because remember, all the while I was struggling with natural language complexity in software engineering. So I started working back again on the problem of software engineering. I
okay.
went back to it, and I've been right now using Gen AI to do bits and pieces of it. I'm planning to work with engineering design department of IIT Madras
Mm.
to basically make it happen. That's what is happening now. But right now I'm doing consulting for the small and medium is close to my heart. Those are the guys who need usable technology now. So I've been working with the paper industry and trying out a lot of this stuff. Let's see how it goes. So right now I'm still pursuing my original dream, 40-year dream of proper software engineering. So that is my life story, Chef.
Yeah, wonderful, Spart. And what you covered triggered a lot of nostalgia also. Things
Yeah.
like the 400 to MT687 and all kinds of things. Okay.
Yeah.
But then, in a way, probably a lot of these developments in technology are also mirrored or reflected in many things that you did, right?
Correct.
See, some of these challenges that you talk about in terms of good software development,
Hmm.
continue to be challenges.
Yeah.
And maybe some different names, different things. You talked about 4GLs. And
4G,
then
case,
yeah, a
all those.
couple of years ago, suddenly everybody talked about low code, no code environments and all.
No, agile, all those
Yeah,
kind of stuff.
and now everybody is talking about vibe coding.
Correct.
But all these things require a person to actually think and then at least specify.
Correct.
So, any thoughts that you have in terms of two things?
Hmm.
One is how do you make specifications a little unambiguous? And two, which is about getting people ready quickly. See, for
Correct.
example, when we started our coding journeys,
Hmm.
we all had to either, even if you don't use it, understand assembly language or look at what the generated code is and then things
Correct.
like that.
Correct.
But after that, when the visual tools started coming in, drag, drop, set some properties, and then, okay, quickly you have something to do.
Correct.
Because, like you said, your code generation thing, the patterns are actually built into the generators.
Correct.
So, like that, if somebody wants to get into, I wouldn't say software development, but solution development, how can somebody be prepared quickly? It takes a long time for you, like you also mentioned that you had to get your code reviewed by others, your design reviewed by the team in
Correct.
Belgium and all that, right? How can that process or the time required to mature be compressed?
See, that is the greatest part, right? That is exactly what I'm working on, right? So, see, what has happened now is with all these years of experience, you have a clear idea as to, see, for example, in agile methodology,
Mm.
about epic stories and story points, correct? There's standard definitions for it and stuff like that. But nobody, maybe they do, but nobody has a clear idea of what should be an epic, what
Mm.
should be a story, what should be a story pile. How does it actually translate into eventual solutions you build, software or whatever it is, right? And the main problem to me in software engineering, teaching software engineering, is the traceability of what you do in the previous step. These things have to be known for even using Gen AI down the line. If this happens, you know what will happen? You will basically know how to prompt Gen AI to get the artifacts for the next level, right? And eventually it'll create code artifacts and you need to know how to build and test it. That's what is going to happen. But humans will never be out of the loop in this particular area as of now. So you can't think of an agentic or agent AI which will do all the stuff for you, because at each point you will have to do the review of what these review people did as to what the system outputs from, even if it uses Gen AI. Comes out, for example, okay, give you a very small example. Take a typical process in, say, my basic specialization or my whole life has been business systems. So I can't claim to know anything about embedded software development or real-time software development. I don't know any of that. I can only talk about transactional business systems, which is what I have been doing for all of my life. Okay? Given these systems, let's take a simple process. Simple process like, let's say, plan to produce in a typical manufacturing organization. So there is planning, there is machine scheduling, there is production booking. These are all standard, right? So what happens is, so in that case, what would be an epic? So these kind of mappings as to how people talk about business objectives or software requirements to how do you take it into software development is the first first gap that needs to be bridged. Then comes, okay, so if I define an activity, business activity that will perform this, how does it become a software system, the user interface, services, backend database stuff? So that is how it needs to be taken in, and that is what I'm basically working on. How to use, because if you realize every activity in software engineering today is a cognitive activity. And by definition, all cognitive activities can be enhanced by the use of GenAI. So all we need to figure out is whatever activity I am doing, how can I use GenAI? That's all, right? Fundamentally. So that's how I approach this, and that's what I'm working on now.
Okay. Yeah, actually, anyway, my perspective is slightly different on this because GenAI can't be a solution for everything because you will need your predictive as well as agentic. It's a mix of all that, how
Correct.
it can enhance the human in the loop. Yeah.
Correct.
So a couple of other related questions quickly, since we probably already have been talking for a while. See, one, you said as a designer or architect, there was one challenge about the ability to think in abstraction. And once you have an abstraction, how can you quickly make it understandable by others? Then I'll come to part two of the question.
See, that's what I'm talking about. You have an idea. So that idea, in my experience in this, is a typical business objective, right? The business objective says that plan to produce, I should be able to track the process, work in progress accounting, basically material accounting. I need to know all the pieces where they are, how many pieces are in each stage. It's a made order, made available, shipped available, whatever model it is, right? So that is what the abstract idea. I need to be able to do it. Then you are basically saying, if I need to do it, then how do you even elicit a solution, like you said, that is understandable to others who are going, particularly who are going to use it? So what are you going to say? You are basically saying that, listen, in this stage, this is what will happen, this is what you will do, this is where you'll use the computer to do it. Deal. So that translation, that abstract to what will happen in my real life. When I come to office tomorrow, if the solution is implemented, what will happen? The ability to relate and show that is the key towards any of this becoming understandable to humans as well as GenAI. That's what I'm trying to say.
Okay. A follow-on question to that is when it is about a specific activity to be done or sequence of steps to be executed, it's probably a little more easier to relate to and also specify.
Okay.
And even as a solution creator, when you talked about, let's say, the SWIFT system, if you take something like the Aadhaar, the Universal Identity System in India,
Correct.
how do you think in scale and how do you engineer something that is not only complex in terms of the number of components you have to have, but also scale in terms of performance when you may not be able to predict exactly what the loads are going to be or what the edge cases are?
Correct. So that is where the non-functional requirements become very important, which is basically saying what kind of technical architecture I'm going to adapt. See, people generally talking about architecture, that's all fine. But to me, it is very clear that there are two areas where architectural decisions have to be made. One is application architecture, the other one is technical architecture. And based on these decisions is how you are arriving at what we call as technology selection. So you make these architectural decisions and then you go look for what technology should I be using? What stack should I be using to satisfy these two kind of architectural decision, not the functional requirements or whatever. These two requirements lead to a tech stack selection, which is what are the technologies? It's like any other engineering, right? So there are these decisions, and you're basically deciding on the material you're going to use to build that machine, right? So that is what I mean by saying both sides are to be considered to do technology selection. And if you have application architecture decisions well defined, if you can make functional, non-functional requirements well defined, there should be a way to bring it together and look at the available set of technologies and make selection. This is something that is what I am also working on this side, not just building, but making these decisions and figuring out what is the technology stack we should be using. Yeah, so that's how I think about it. And I'm 100% sure that these two areas are also areas where Gen AI will be very useful.
Yeah, on that positive note that there is still work for all of us. There is the humans. And yeah, a lot of things can be accelerated and done a lot better, a lot faster now. Yeah. So
See,
that,
Gen AI to me is like artificial general intelligence. Maybe when it comes, I don't know. But right now, I think of it as a cognitive enhancer for those activities which are highly cognitive.
yeah.
So on that note, like you said, with great positive hopes for Gen AI, I'm working on this area now. Finally, software engineering and Gen AI is coming together.
Thanks a lot, Spart, for this very brief walk through history. Yeah, all the exciting things that you're doing. Yeah, all the best.
I hope it is interesting to people who listen to this.
We thank Siddharth for the music and Anita for promoting the Software People stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.